Welcome back to Dunwoody College of Technology, Mechanical Engineering, Electrical and Controls class, where we're practicing Karnaugh maps. So we've done a couple of them already. We did this problem 1 and problem 2 in other videos. And now we're going to move on to a 4-input Karnaugh map. So we have A, B, and C, D as our inputs, and we get Y in this truth table, and we're going to make that Karnaugh map. So I'm going to work over here on the right side and transcribe this information onto the Karnaugh map. So as opposed to 3, we have to have AB on one side and then CD on the other. So instead, before we had A down here and then BC here. Now that we have a fourth, we have to combine that together. And now, since we have AB in this column, we're going to have 0, 0, 0, 1. Then we skip 0, 1, 0 and put in 1, 1. Then we go down back to 1, 0 again. We get the same thing on the columns here. So we have 0, 0, 0, 1, 1, 1, and 1, 0. So now we'll transcribe that information over. Sorry about the squiggles there. So we start here. Here's our 0, 0 section. So this first 4 will be our top row. And so we go 0, 0, we get 1. 0, 0, 0, 1, we get 0. Then we skip row 3, go down to here. We get 1, 1 is 0. And then we have a last 1. Now 0, 1 is our next 2 sets. So 0, 1, 0, 0 is 1. Looks like all 4 of these are 1s here. Just looking across, so I can just put 1, 1, 1, 1, 1, 1. Alright, now we need 1, 1 here. See, 1, 1. We skipped 1, 0, so we're going to go down to the last set of 4. And looking across there, we have to be a little careful, but we have 0, 0, 1, and then we have, over here we have, for a 1, 1, we have 1. Then going back up to row 3 from the row 2 from the bottom, we have 0. All right, now we go back and get 1, 0. Oh, I wrote this in the wrong way. It rotated on me. 0, 1, 0, 1, 1, 0. Let me erase these. Come on. Let me erase that. Alright, well that one's being stubborn. I don't remember if that has to be a... There we go. Alright, coming back. So 1, 0, 1, 1. 1, 0, and then whatever. So we have 1, 0, 0 is 1. 1, 0, 0, 1 is 1. And then the last 2 here are 0 and 0. Alright, so there's our Karnaugh map. And we need to find groups of multiples of 2, or of powers of 2. So we've got a few choices here. I could take this group of 4 here, and then another loop of 4 there. Let's have this group of 2 here, and this group of 2 here. That ends up with 4 groups. That might be a little more than I want. I can also go this way. So there's one group. And then get these 4 in the middle. Gets me a second group. And then I can take these last 2, and that gets me 3 groups. So I'll have a sum of 3 products together here. And just like we did with the other ones, with 3 inputs, we're going to do the same thing here. So what's changing from this row to this row? Our B value is changing, so that's not going to have an impact here. So we won't see B in that expression. And then going from this column, we have 0, 0 to 1, 0. C is changing between those two. So we won't have C in this. So we're going to have our A component, which is going to be not A. And what's not changing from this one to that one? It's D, which is not D. Alright, so that was from this first group that wraps around. Now another group of 4 is here in the middle. So it's changing here. A is changing, it's going from 0 to 1. And then going from this way, we have 0 to 1 here in our C. So we're not going to have A or C. What is B? B is 1. D is also 1, so we just have B, D for that term. Alright, and then last we have this term here. So we're only in this row, so we're going to have A and B are going to be constant, so that's a little unfortunate. So we have both of those. A is going to be 1, B is 0, so it's going to be not B, and we have C is 0, D is changing, so D won't be in there, so we get C not, since that was a 0. So my expression then will be not A and not D, or B and D, or A and not B and not C. Alright, so there's our Karnaugh expression, or our expression for this truth table using our Karnaugh map. Let's double check and put those values in back and make our truth table here. So just in the interest of time, I'm going to erase this guy, hopefully, there we go, and these guys, just to have a little room. Alright, so A and D, when A and D are 0, that's 0 makes a 1, 0 makes a 1, that's 1. Perfect, everything else is sum, so I know that's going to be a 1. Alright, next row down, A and D are now 0, 0 and 1, so that's no longer 1. B and D, 0 and 1, not 1. And then A is 0, so that makes a 0 for those 3 terms. Alright, next row down, A and D, not A is 1, not D is 1, multiplied together is 1. Oh, my 0 disappeared in that row. So that got me a 1 from this bit, so it didn't really matter what anything else was after that. I had that value. Moving on, A is 1, not A is 1, not D is 0, so that's 0. B and D, B is 0, so that makes that 0. A was 0, so that makes that 0 as well. So we finished our first bit. Now moving on to the next row, 0 and 1. So A is 0, D is 0, not both of those, gets us 1 and 1 multiplied together, gets us 1. So from that first term again, we get 1. Next row, A is 0, makes that 1. D not is 0, so that's 0 this first term. B is 1, D is 1, so and 1 and 1 is 1, so that gets us a 1 from that second term. Moving on, our third row here, B is 1, D is 1, that gets us a 1. Did it disappear on me? 0 and 1, and 0 for A not makes 1, D not makes 1, so we add those together, we get, or multiply those together, we get 1. Last one, yeah, they are disappearing on me. Last one, A is 0, so that makes 1, D is 1, that makes 0, so I don't get anything from that first term. B is 1, D is 1, B and D together is 1, so I get a 1 from this second term. Alright, moving on. Okay, this is getting frustrating. There's 1. Don't disappear on me. Alright. Next row, 1 and 0. That's not 1 from this term. B and D, not 1. Okay, so A and not B and not C. A is 1, B is 0, so not B is 1, not C is 1. That makes 1. Alright, so our third term there got us our 1 there. And computer doesn't like that, apparently. Next row, A is 1, D is 1, so that's 0 for our first term. B and D, 0 and 1. That's not there. But we get the same. A and not B and not C is the same thing as our last one, so we get that 1 from that third term again, if it will stick. And then our next row here, 1 and 0, that makes us 0 for our first term. B and D, 0 and 0. A and not B and not C. Oh, not C is 0, so that also makes it 0. My 1 keeps disappearing. And lastly, not A and not D makes 0. B is 0, D is 1, that makes 0. A is 1, not B is 1, not C is 0. So there it is. And down the home stretch, we've only got a quarter left. Not A is 0 times not D is 0. B is 1, D is 0, so that second term is 0. And then A is 0, not B is 0, so that makes 0. Alright, A and D, that makes 1. Not A and not D, excuse me, so that's 0. B and D, there's where we get our 1. B is 1 and D is 1. 1 and 1 is 1. Next row, not A is 0, D is 0, so not D is 1. That makes a 0. B and D, B is 1, D is 0, that's 0. Not A is 1, not B is 0, so that makes that a 0. Lastly, not A, not D is 0. B and D, 1 and 1 is 1. So we get the exact same thing we had in our truth table. So this expression does get us this truth table here. So a little bit more work. We have twice as many entries in our Karnaugh map, and if we couldn't have simplified this more, and we kind of lucked out that we had 2 groups of 4 and 1 group of 2, so we only had 3 components to this. If we had another one there, I would have had even more mumbling as I went through the truth table building. But we can see that not A and not D, or B and D, or A and not B and not C is an expression that gets us this truth table. And so if we try to draw what that looks like for a Karnaugh schematic, we'd have not A and not D. This is A, here's D. I don't know why I skipped it out of order. And these are all going to go into an OR gate somewhere. Then we have B and D. So we're going to tie off of this, come down. Here's B. And then we have A. I'm going to pull that around this way. And not B. And not C. So we have C here. So I'm showing it as a 3-input AND gate. And then these are going to go into a 3-input OR gate. So that would be our schematic for that truth table and Karnaugh map, or that expression.